Okay, the combined gas law is P1 times V1 over T1 equals P2 times V2 over T2. P is pressure, V is volume, T is temperature. Temperature has to be in Kelvin. That means you take degrees Celsius, you add 273, and it gives you Kelvin. Pressure times volume is directly related to temperature. That means if I increase temperature, I increase the pressure times volume. The variable that is constant here is moles of gas, which is N. So let's take a look at student exercise 5A. A sample of gas has an initial volume of 158 milliliters at a pressure of 735 millimeters of mercury and a temperature of 34 degrees Celsius. If the gas is compressed to a volume of 108 milliliters and heated to a temperature of 85 degrees Celsius, what is the final pressure in millimeters of mercury? Okay, so I write it out like this. Notice my volumes are in milliliters, my pressures are in millimeters of mercury, and I've got to convert my temperatures to Kelvin. Your units have to match. So 34 plus 273 is 307 Kelvin. And then 85 plus 273 is 358 Kelvin. Okay. So now that all of my units match, I can substitute all of the numbers into the equation and cross multiply. Okay, so here are the numbers in my equation, and you want to cross multiply, so we're going to multiply 735 times 158 times 358, and then set it equal to P2 times 108 times 37, and I'm going to write that out for you. So you cross multiply, okay, and you get it set up like this, and then you want to solve for P2 by dividing both sides by 108 times 37. Okay, so I'm going to figure out what 735 times 158 times 358 is first. Then divide it by parentheses 108 times 307. If you don't include parentheses and you're trying to do this all in one step, it's going to take 358 and divide it by 108, and that's how you'll get the wrong answer. Okay, so for P2, I got 1253.9, but since I had three significant figures as being the fewest sig figs in any number that I had in my original answer, I want to take this and round it off. So I'm going to underline the 125. Since after the 5 is the 3, you want to round it down to a 0. So 1250 millimeters of mercury is your final answer. Okay. Let's try 5B. If 22 liters of N2 at 25 degrees Celsius and 725 torr are heated to 134 degrees Celsius and compressed to 4.50 liters, what is the new pressure? Okay, so I line up everything like this. My volumes are both in liters. My temperatures need to be in Kelvin, so let's convert that now. 25 plus 273 is 298 Kelvin. And then 134 plus 273 is 407 Kelvin, like that. Now I can go ahead and put my numbers into the equation. So it's 725 times 22 divided by 298 equals P2 times 4.50 divided by 407, like this. You want to cross multiply to solve for P2. So you're going to get it set up like this. And then we're going to divide by 4.50 times 298 on both sides. So 725 times 22.0 times 407. Get that answer first and then divide it by parentheses 4.50 times 298. And you're going to get 4840.9. I'm going to underline the 4840. I want 3 sig figs because those are the fewest sig figs I had in any answer that were in the original answer. So after the 4 is a 0, so I don't have to round up. So it's 4840 torr for your final answer. And that's it. Okay. Now, a couple things about the worksheet. You have to do the work on a separate sheet of paper because there's not enough room on the worksheet to do it. So it looks like this, okay? And a couple things that you need to be aware of. Number one, a gas has a volume of 800 milliliters at minus 23 degrees Celsius. Minus 23 degrees Celsius means negative. A lot of students miss that. Okay, I expect you to read the entire problem, okay, when you're doing this kind of stuff. So I'm just pointing some things out to you so that you don't miss some points. Another thing is that you have to make sure that your units match. So let's take a look at number 2. You've got P1 as 700.0 millimeters of mercury, and then you have your P2 as 30.0 ATM. Do those units match? No, they do not. On page 2 of the chapter handout, I gave you the unit conversions, and I told you that 1 ATM equals 760 millimeters of mercury. Okay? So you're going to be using that conversion to either convert millimeters of mercury to ATM or ATM to millimeters of mercury. Okay? You have to do that before you go putting your numbers into the equation and solving for anything. Okay? Another thing you need to be aware of is they talk about STP, which we briefly talked about in a previous chapter. So if you take a look at question number 6, you've got a gas with a volume of 34.2 milliliters at a temperature of 15 degrees Celsius and a pressure of 800 torr. What will be the volume of this gas at standard conditions? Standard conditions means you're at STP. That means you're at a pressure of 1 ATM and a temperature of 0 degrees Celsius. So you need to know that. You need to make a note that anytime it says standard conditions or STP, that is either where you are going to, if it's referencing going there, or if that's where you're coming from, if it's talking about beginning there. Okay? So in this problem, your T2 is 0 degrees Celsius and your P2 is 1 ATM. And what you should immediately notice here is your pressure units do not match. You have P1 in torr and P2 in ATM. Okay? In the chapter handout, it says that 760 torr equals 1 ATM. So you have to use that. To do some unit conversions, either convert torr to ATM or ATM to torr. They just need to match before you go putting them in, okay? And then number 7 talks about standard temperature and pressure. Number 8 talks about STP. Number 10 also references STP, as does 11. So you just need to take it slow and make sure that you label things this way first and check all of your units to make sure that they match. And that is it. This assignment is going to be submitted on Canvas. Your answers have to be to the proper number of significant figures. You have to have the right unit. I specifically tell you in the directions how to type in your unit, like a capital L for liters, a lowercase m, capital L for milliliters. And you have to put a space between the number that you have and the answer. And this is clearly stated in the directions. And I talk about it in class.